So in your previous session, we have studied about the electrolysis concept, that is electrolytic cell concepts. So in this session, we will be studying about electrochemical cells concept, that is electrochemical cells. So electrochemical cell. Cells. These are also called as voltaic cells. Or it is also called as galvanic cells. Galvanic cell, electrochemical cell, voltaic cell, or it is also called as galvanic cell. All are one and the same. So in your first session itself, the introductory session of this electrochemistry itself, I have told you that there are two different concepts that has to be studied in this electrochemistry. The first concept we were discussing till your 8th session was your electrolytic cells, wherein you have a redox reaction. It is non-spontaneous and you are using electrical energy to convert your non-spontaneous redox reaction into spontaneous redox reaction. That is, you are making a non-spontaneous redox reaction spontaneous by using electrical energy. Simply telling, you are using electrical energy, converting it into chemical energy. That is, making a chemical reaction feasible with your electricity. This is the branch of electrochemistry wherein you have opposite of that. That is, there is a spontaneous redox reaction. It liberates some chemical energy. That chemical energy you are converting it into electrical energy. So, electrochemical cells have redox reactions, spontaneous redox reactions, spontaneous redox reactions. So, what do you mean by spontaneous? Spontaneous means the reactions which happen by itself, that is, it doesn't require any external aid. Redox reaction, what is redox reaction? It's a simultaneous reduction and oxidation reaction. What is reduction? Addition of electrons in terms of electrons. Since we are talking about electricity. Oxidation, it is removal of electron. So, you have a spontaneous redox reaction which liberates, which produces some chemical energy, which produces some chemical energy. This chemical energy, you are converting it into electrical energy, through a suitable setup. You require a setup for that, suitable setup. Let us see what is that. Suitable setup, which is nothing but your electrochemical cell. Electrochemical cell. So, electrochemical cell is a setup wherein you convert your chemical energy that is produced by your spontaneous redox reaction into electrical energy. So, such types of setup is called as their electrochemical cell. As you know, cell is nothing but a setup of an anode and a cathode as well as an electrolyte. So, in detail we will be seeing about this electrochemical cell, which is very important in your daily life as batteries. In your first session itself, I have told you many batteries, watch cells, etc. are based upon this concept of electrochemical cells. That is, all your batteries, cells have chemical energy inside it, that is chemical reactions happening inside it, which will be converted into your electrical form of energy. So, as a result, it is very important. So, hence we will be studying in detail about electrochemical cells. So, very simple, electrochemical cell is a suitable setup which converts chemical energy into electrical energy. How is this chemical energy coming into existence? That is, it is produced by a spontaneous redox reaction happening inside the cell. So, before describing what is a electrochemical cell setup, how is it set up, I want to explain a small experiment wherein you will know why is this electrochemical setup is required to convert your chemical energy into electrical energy. Say I have a beaker. This beaker contains your copper sulfate solution. Copper sulfate solution. You know this is blue in color. You know it is blue in color. Into this I will be dipping a zinc rod. This is a zinc rod. zinc rod. It acts as an electrode, this acts as an electrolyte. So after dipping the zinc rod into copper sulfate solution, as time passes, you can observe that the zinc rod goes on thinning. It happens to be like this. It goes on thinning like this. That is, the thickness of zinc rod will be reduced. Thin aagta hogutte. That is because the zinc ions present in the zinc rod will be entering your copper sulfate solution as Zn plus 2 electrons. So zinc ions will be entering your copper sulfate solution. As a result, zinc rod goes on thinning. So you know, this is a simple oxidation reaction. It is a simple oxidation reaction. As well as your copper ions present accept these electrons, that is copper ions are present in copper sulfate solution. They accept these 2 electrons, Ce2 plus 2 electrons. It becomes solid. This is aqueous, this is solid. That is, they get deposited here under the zinc rod. This will be a red precipitate. So, take a copper sulfate solution, dip zinc rod. Zinc rod goes on thinning after time passes. That is because zinc atoms, that is the elemental zinc that is present in the rod, will undergo oxidation. They liberate electrons. These electrons are accepted by copper. This is nothing but simple reduction reaction. So, they undergo precipitation under the zinc rod. This means that oxidation and reduction are happening spontaneously as time passes in a single cell, that is in a single container. If you check the temperature of this container, that is if you check the container temperature of this container, it will be increased. Temperature will be increases. That is before dipping the zinc rod, and after dipping the zinc rod, if you take the temperature reading of this cell, it will be observed that temperature has been raised, which means that this spontaneous reaction has produced some chemical energy, which has been converted into your thermal energy. So chemical energy is this redox reaction happening spontaneously. So as a result, this reaction liberates some energy in the form of heat that is converted into your temperature, that is nothing but your thermal energy. But here it is impossible to convert your chemical energy that is produced by redox reaction, spontaneous redox reaction, into your electrical energy. That's the agenda of your electrochemical cell. That is, in single containers like this, you cannot convert your chemical energy produced into electrical energy. As a result, such a special setup is required to convert your chemical energy into electrical energy. So now let us see what is this special setup which converts the same chemical energy into electrical energy. Here it is only into thermal energy, which is not of so use. So the agenda is to convert this chemical energy of this redox reaction into your chemical energy. So that agenda is your electrochemical cell. So now we will be discussing in detail about this electrochemical cell, which is a special setup which converts your chemical energy into electrical energy. There are a lot of examples that can be taken for electrochemical cell explanation. Your nickel cadmium battery, your nickel silver batteries, lead sulfate batteries. So like this, a lot of examples can be taken. Here we are taking an example of electrochemical cell, that is your Daniell cell. Daniell cell. It's a zinc copper cell. Zinc and copper cell. It's just an example of electrochemical cell. It has the same working principle as your electrochemical cell, that's your Daniell cell. It is a zinc copper cell. So let us see what is this Daniell cell is. You have a container number 1 in which you have filled your zinc sulfate solution. Into which you have dipped a zinc rod. This is a zinc rod. So this is container number 1. This is your second thing, that is second container, which is filled with copper sulfate solution into which you have dipped copper rod. These two rods are connected to an voltmeter or an ammeter or voltmeter, both can be attached. So this is the setup of your cell, Daniell cell. So zinc rod dipped inside the zinc sulfate, copper rod dipped inside the copper sulfate solution. Externally it is connected to a circuit through an ammeter. So you can observe that if it is a single chamber, you cannot convert. So from this you can observe that if it is a single chamber, single container, you cannot convert your chemical energy into electrical energy. As a result, here I have taken two different containers wherein zinc rod is dipped in zinc sulfate, copper rod is dipped in copper sulfate connected through a external circuit through your ammeter. Now the thing what happens is, in this first container, the zinc rod, atoms of zinc will be undergoing oxidation and they enter your zinc sulfate solution as zinc ions, like this. That is, the atoms in this zinc rod will lose electrons and form zinc ions and they enter aqueous medium. That is, Zn give rise to Zn2 plus 2 electrons. That is, oxidation will be happening. Since the zinc ions will enter your aqueous medium, that is your electrolytic solution, zinc sulfate solution, the electrons, the two electrons that will be present will be moving through the outward circuit. That is, the zinc ions enters aqueous solution while the electrons will be moving outwards in this direction. You can observe that this rod, which is losing zinc ions, is rich in electrons. As a result, the electron charge is negative. So this rod is rich in negative charges. As a result, this becomes negatively charged electrode. So this becomes your negatively charged electrode because the zinc atoms in your zinc rod loses electrons, zinc ions enter aqueous solution, electrons move outwards through the external circuit. They move outwards through the external circuit. As a result, this rod becomes electron rich. As a result, you get your negatively charged electrode for this electrode. The electrons will be moving towards this electrode and it will be entering this electrode. The copper ions that is present in your copper sulfate solution. So this is your copper sulfate solution, electrolyte. The copper ions present here will accept the two electrons from the rod. That is, they will pull out the electrons that is coming from the external circuit and they get reduced. Cu2 plus 2 electrons, solid, aqueous. Here it is solid, they enter your aqueous medium. So copper ions that is present in your aqueous medium, they grab out the electrons that is coming from your negatively charged electrode. As a result, they get reduced into copper atoms. Since the electrons are pulled out by the ions that is present, this rod now becomes electron poor. As a result, this becomes positively charged electrode. So this is electron rich, it is moving outwards. As a result, it is a negatively charged electrode. This electrode is having, that is the copper ions will be grabbing out the electrons from the electrode. As a result, this rod will be in loss of electrons. As a result, it becomes a positively charged electrode. Here in electrochemical cell, the negatively charged electrode here, it is called as anode. Very important, it is called as anode. Remember, anode here it is negatively charged. Remember, in any cell for that matter, whether it is a electrochemical cell or it is an electrolytic cell, the left hand side electrode that is present on the left hand side is always called as anode, and left hand side always you will be having an oxidation reaction. But in electrolytic cells, you call it as positively charged thing, that is anode is positively charged, but in electrochemical cell it is negatively charged. For this simple, I will be giving a code. A code is called as, to remember this anodic thing, we will be giving a code called as LOAN, L-O-A-N. Till here it is common for even your electrolytic cell or your electrochemical cell. What is common? L is left side, O is oxidation, A is anode. So till here it is same for electrochemical cell as well as electrolytic cell. If you look into my second session, you can observe that left side is anode itself and it is happening oxidation itself. But here it is negatively charged. So LOAN, left side, oxidation, anode, it is negatively charged. If it is an electrolytic cell, you have to think that it is positively charged. It is opposite of this one. So remember this code to remember what is happening on which side, which will be helpful to write down your cell representation as well as your problems, numericals based upon this electrochemical cells. So remember this, left, oxidation, anode, negatively charged. For electrochemical cell, for electrolytic cell, till here it is same, left side, oxidation, anode, but it is positively charged in your electrolytic cells. Obviously, if this is anode, this is your cathode. This is your cathode. Cathode here it is positively charged. In electrolytic cells, it is negatively charged. So cathode obviously is opposite of this one. L, cathode is right side. Oxidation, obviously cathode undergoes reduction. Anode, it is cathode. Negatively charged, cathode is positively charged. So as a result, you can, if you remember this LOAN, it is obviously the opposite of this for your cathode. So this is about your cell setup. So very simple. Your first chamber has zinc sulfate solution, electrolyte, zinc rod is dipped. Second chamber has, so this is reduction. So the second chamber has copper sulfate solution into which you have dipped copper rod. So copper ions undergo reduction. So the zinc ions enter your aqueous medium, electrons move through the outer circuit. These outer circuit electrons are grabbed by the copper ions in your copper sulfate and they get reduced into metallic copper. These metallic copper deposit over your zinc rod, that is copper rod. The zinc rod gets thinning. The copper rod goes on thickening, that is, since zinc ions are living out of your rods, it goes on thinning. The copper ions goes on building up this because copper will be deposited more and more. Since the electron moving from your anode to cathode, the current will be moving from cathode to anode. So this is your electron movement, this direction, while current is in the opposite direction. Current is in your opposite direction. That is because, as you know, your current will be flowing always in an opposite direction to the flow of electron, which is called as conventional current. I think you have studied in your physics, current electricity. Everywhere, wherever you see an electron passing in one direction, the current will be flowing in the opposite direction. Hence, it is called as your conventional current. So, obviously, electron flows from anode to cathode, while current flows from cathode to anode. So, this is about your cell setup of your Daniell cell. As the current flows, that is, as the electrons flow from anode to cathode, the current will be flowing from cathode to anode. The zinc ions will be entering your zinc sulfate solution. The copper ions will be accepting a pair of two electrons from your metal rod and will be getting deposited over your metal rod. As time passes, what happens is, the zinc ions concentration in this chamber 1. So before that, I will be telling that this half cell, so the one chamber here which is present is called as a half cell. So this is one half cell and this is the other half cell. So this half cell is called as, since oxidation is happening, it is called as oxidation half cell. And the reaction which is happening is called as oxidation half reaction. Remember, this is oxidation half cell. So this is your oxidation half cell. Since oxidation is happening, it is called as oxidation half cell. So this is the other half cell, this is the complete cell, this is another half cell which is called as reduction half cell. reduction half cell. Half cell. So oxidation half cell, reduction half cell. The complete cell is of your both the half things, which is completely called as your Daniell cell. So as the zinc ions enters from your rod to your zinc sulfate solution, obviously your zinc ion concentration goes on, increases in this first chamber. As well, here since the copper ions will be getting deposited over your copper rod, the copper ion concentration goes on, decreases in this second chamber. So first cell and the second cell. So here what happens? The zinc ion concentration increases. Here what happens? The copper ion concentration decreases, which means that sulfate ion, that is the other sulfate ion which is present, its concentration will be increasing. That is, the sulfate ion concentration will be increasing. As time passes, as the electricity will be flowing through the circuit, the zinc ion concentration increases in this first cell. Here in the second cell, the sulfate ion concentration goes on, increases. As a result, the electrolytic solution here in the first chamber, that is your oxidation half cell, the electrolytic solution becomes more positive. The solution becomes positive. Here in the second chamber, since sulfate ion, since it is negatively charged, since sulfate ion concentration is increasing, that is because copper ions are decreasing, the concentration of sulfate ions increasing, the second solution becomes negatively charged. That is, the zinc ions that is produced more and more will deprive the electrons from moving to the outer circuit. That is, these zinc ions crowd up here like this. They crowd up like this. Its concentration has been increased. As a result, they crowd up like this so that they will not leave the electrons to move to the outer circuit. That is nothing but if the electrons are not moving through the outer circuit, which means that there is no electron flow through the outer circuit. Since there is no electron flow through the outer circuit, it means that there is no current flow through the electrons, that is through the circuit. So this will be happening for a long time, and finally what happens is there is no electricity passing through the cell. So that's the point wherein you can observe that there is no electricity is passing. That is because these zinc ions will deprive the electrons to move to the outer circuits. Since the outer circuits will not have any electron flow, the copper ions cannot accept any electrons. As a result, the current flow through the circuit will be zero. So hence, this building up of charge in your oxidation half cell as well as your reduction half cell should be reduced. So what the ion has been increasing here as well as here should be neutralized. That is, the electrical neutrality should be maintained in the chamber 1 as well as in the chamber 2 also. So electrical neutrality, if it is maintained, obviously there will be an electron flow through the outer circuit and there will be a continuous electricity flow in your cell. So this is made, that is the electrical neutrality which has to be maintained in your oxidation half cell as well as reduction half cell is made by a special apparatus which is called as your salt bridge. Salt bridge. So there is a salt bridge, that is a special apparatus which maintains electrical neutrality. That is, the increased positive charge here, the increased negative charge here has been neutralized by this special apparatus called as salt bridge. So let us see what is this salt bridge is. See, salt bridge is a bent glass U-tube. You have to take a bent glass U-tube like this. U-tube, into which you are adding an electrolyte, an inert electrolyte plus an agar-agar solution. So into this you will be filling inert electrolyte plus agar-agar solution. So inert electrolyte can be either KCl, KNO3, etc. Any of the thing can be your inert electrolyte, KCl, KNO3, etc. Into which you are adding this agar-agar solution. Agar-agar solution is nothing but upon solidification becomes a semi-solid thing which helps in movement of these ions in the mobility of these ions. So this is an semi-solidification substance upon exposure to your atmosphere. So we have to mix these two things, inert electrolyte and agar-agar solution, and I have to fill into this salt bridge. Fill into this salt bridge. So let us see what is the function of the salt bridge now. As you know, it is your maintaining electrical neutrality in your chamber 1 as well as chamber 2. Let us see how it is maintaining your electrical neutrality. Say for example, this salt bridge is KCl salt bridge. Think that this is a KCl salt bridge. You can also use KNO3 also. So, since it is an electrolyte, they get ionized into K plus and Cl minus ions. K plus and Cl minus ions. The K plus and Cl minus ions, you can observe it's a cation and an anion. They move towards respective chambers. That is, the Cl minus ions, they move towards this first chamber. The K plus ions move towards this second chamber. I think you understood now. Since this first chamber is rich in positive ions, that is the solution has become positive, the negative ions coming from the salt bridge neutralizes the positive charge present in your first chamber. The same thing for your second chamber, that's your reduction half cell. The K plus ions move into this chamber because this chamber, the electrolyte is more negative, it has become more negative. So positive ions will neutralize the negative charge that is present in this solution. As a result, they neutralize the charges, extra charges that is present, excess of charges that is being produced inside the chamber. As a result, they maintain electrical neutrality. Once the electrical neutrality is maintained, these zinc ions remain neutral, that is they get neutralized by these Cl minus ions. As a result, this crowding up along the electrodes will be decreased. Since this crowding up along the electrode is reduced, the electron will easily flow through the outer circuit, hence there will be a flow in current. Obviously in this chamber, the sulfate ion concentration has been increased, it is neutralized by K plus ions. As a result, these copper ions will be easily grabbing the electrons that is coming out of the circuit and they will be getting reduced. So hence, this salt bridge, by movement of respective ions to the respective chambers, that is your oxidation as well as reduction half cells, they maintain neutrality, electrical neutrality, and they help in continuous flow of electricity through your circuit. I have told you here it is inert electrolyte. You have to use an inert electrolyte in the salt bridge. Remember, the salt bridge function is only neutralizing the charges that has been produced in excess in your chambers. That is, they have to just maintain the electrical neutrality. Hence, it should not react with your ions that is present in your electrolytic solution. Neither they have to react with your rods that has been dipped. That is the meaning of this word inert. That is, the electrolyte that is used in the salt bridge should not react with any of the ions or your rod that is present in the half cells. That is the meaning inert. So you have to select such an electrolyte which will be not reacting with the either of the chambers rods or either of the chambers ions. That's the meaning you have to use an inert electrolyte. Along with that, while using a salt bridge, you have to take an inert electrolyte. Along with that, you have to see that the electrolyte taken whose ions have higher mobility. That is, the mobility of these ions should be greater. That is, the movement of these ions should be very higher such that they easily pass through the two chambers so that they maintain electrical neutrality. So, inert electrolyte as well as the ions of the electrolyte should have higher mobility. So, salt bridge is a bent U-tube into which you have to fill two things. One is an inert electrolyte and an agar-agar solution. So, inert electrolyte means it should not react, that is the electrolyte used in the salt bridge should not react with the ions or the rods of the chambers. The ions that is used in the salt bridge, that is the electrolytic ions used, should have great mobility so that they can move faster, as well as your salt bridge maintains your electrical neutrality. Also, it completes the circuits. It loop ups this circuit. As a result, it will be having a continuous flow of the current in the circuit. So, this is about the complete picture of your Daniell cell. So, summarizing, it has two chambers. The first one is oxidation half cell. The second one is reduction half cell. The first one, oxidation half cell, has zinc sulfate solution into which zinc rod is dipped. Second cell, copper sulfate, into which copper rod is dipped. It is connected externally through an external circuit through your ammeter or a voltmeter. So, here zinc ions enter from rod to aqueous solution, electron move towards outer circuit. Here copper ions present in your aqueous solution grab out the electrons and they get deposited over your copper rod. Since this is electron rich, electrons are moving outwards. Since this is electron rich, it is negatively charged. Since the electrons are grabbed out of the rod, this is positively charged rod. The negatively charged rod, since it is present on the left side, it is called as anode, and the reaction happening is oxidation. The right side one, it is always called as cathode. It is positively charged and reduction is happening at the cathode. Since the ion accumulation goes on, increases in the chamber 1 as well as chamber 2. Chamber 1, positive ion accumulation goes on, increases. In the chamber 2, sulfate ion, that is negatively charged ion accumulation goes on, increases. In order to maintain electrical neutrality, in this sense, in order to have a continuous flow of electrons, in order to flow of continuous current, you have to use a salt bridge. What is the role of salt bridge? Mainly, it maintains electrical neutrality. How it maintains the electrical neutrality? The electrolyte taken inside will move to the respective chambers and they neutralize the respective charges. As a result, you will be having a continuous electricity flow through the cell. So, this is the picture that depicts your electrochemical cell, and the example we have taken is very important, Daniell cell. The voltage capacity, that is the cell capacity, that is Daniell cell capacity, is your, that is 1.1 volt. The EMF of this cell, I will tell you what do you mean by EMF, but remember EMF of the cell, Daniell cell, is 1.1 volt. We will be calculating the EMF of the cell, Daniell cell, we will be knowing what do you mean by EMF of the cell. But remember, the electrode potential, that is the EMF of the cell, is 1.1 volt.